So today, class, we are going to look at the notes very quickly for section 3D, which is writing formulas and naming compounds. A formula is nothing more than a group of symbols that represent a compound. It's going to show you the elements that are participating and the ratios in which they are participating. So there are four important terms that you have to know. And I'm going to go over those real quickly for you, and so that you understand what they mean. So the first one is a subscript. It is the small number below the formula. Sub means below. Think of a submarine. So it shows you how many atoms of each element combine to form a compound. So you have the example there, H2SO4. So here we have H2SO4. This tells you that there are two hydrogens in one unit of this formula, 4 oxygen, and because there is no number here, it's assumed to be a 1. Whenever there is no number in chemistry, it's assumed to be a 1. So we have 2 hydrogens, 1 sulfur, 4 oxygens. The 2 and the 4 are subscripts. Okay, we never write ones. The coefficient is the large number in front of or to the left of a formula. And it's going to tell you how many units there are. So, for example, the example that I give you is that there are 5 CO2s. This means that there are 5 molecules of carbon dioxide. There is no number with the carbon. There is no subscript, so it's assumed to be a 1. And there's 2 for oxygen. So for every molecule of carbon dioxide, there's a 1:2 ratio of carbon to oxygen. But there are 5 units or 5 molecules of CO2. The 5 is the coefficient, okay? The oxidation number is, you can go through and read that in Birch World, it is the charge, okay? So, the other day, I told you that I thought it was a good idea that you take your periodic table and with some number, or some color, you write group, which I did here, in red, and then I numbered them 1, 2, and then 13, 14, 15, 16, 17, and 18. I just didn't do the ones in the dip, okay? I took another color, and I think this is when I told you to do this. I used blue for this, and I wrote VSE, so valence shell electron. Everybody in group 1 has 1. Everybody in group 2 has 2. You skip the dip. Here you have 3, 4, 5, 6, 7, and 8. Okay? Take another color now and write oxidation number up here. I use green. Use whatever color you want. And here is the pattern that you need to know. Okay? Everybody in group 1 has a +1. Everybody in group 2 has a +2. You skip the dip because they can have more than one oxidation number depending on what they bond with. Everybody in the boron group has a +3. In the carbon group, they can have either a +4 or a -4. It depends on what they bond with. Well, and it depends on if it's a metal or a non-metal. Because you see here we have some metalloids in this group. So a plus or a -4. -3, -2, -1, and 0. These guys don't bond with anybody. They're very stable. They're the noble gases, remember. Okay? That pattern you need to know. Not hard. +1, +2, +3, plus or -4, -3, -2, -1, and 0. Unlike math, you have to write the plus or minus sign every time. Well, I guess you have to do the minus sign in math, but you don't have to do the plus sign. You have to show a sign in chemistry. Okay, so that is the oxidation number here, the charge. When we write it as a superscript, which is a small number above the formula. It's what shows the oxidation number. So here I have an example of a positive one, which is called the anion, and a negative one, which is called the anion. So beryllium has a +2 charge. If we look on our periodic table, you see that beryllium is right here. I look up here and oh look, it has a +2 charge. So we write that as a superscript. You can also write it 2 with a plus behind it. I usually write it like that. Here I show you an anion. Nitrogen has a -3 charge written as a superscript. Again, nitrogen is here. I look up above and oh look, there's a -3 charge. Okay, so that's where you get your oxidation numbers from. The only other thing that you have in your notes is ionic bonds and covalent bonds, which we've already talked about. But I just want to remind you that ionic bonds, there's a transfer of electrons, and covalent, there is a sharing of electrons. When we go to name the binary compounds, which are made up of 2 elements, you are going to have to look to see if they are both nonmetals or if one is a metal and one is a nonmetal. And there are different rules for naming depending on that. So just to remind you very quickly, here is the stair steps. Everything to this side, the left side, is a metal. Everything to the right side of the stair steps is a nonmetal, and that is right on the periodic table of elements that I gave you to use.